Orbit is the eye socket. Eyelids are obviously eyelids. Not going to ask those. Not going to ask eyelashes either. The levator palpebrae is the muscle that lifts or elevates your eyelid. That's this one way at the top. And I like this model the best for the levator palpebrae. Lacrimal apparatus has to do with producing tears. The lacrimal gland is this on the outside. So it's up high, lateral. Here is another lacrimal gland. It's the same idea. The lacrimal canaliculi. Oh, we're missing part of this one. Hold on one second. Lacrimal canaliculi, see the little wishbone shape right here? That's them. The top one is the superior canaliculus, and the bottom one's the inferior canaliculus. Lacrimal sac is this little pink bag that the canaliculi feed into.
Is it the one? It's like the top of the wishbone, or the thing that's on the nose?
The thing that's on the nose. Well, on the side of the nose. Around here, it's kind of bigger, so it's a little easier to see. It's this big blob right here, the big pink blob. The caruncle. You know when you look at somebody in the corner of their eye, there's that pink triangle. That's the caruncle. They're right here. And then the nasolacrimal duct is the tube that leads down to your nose. The canthuses, those are just the corners of the eye. So the lateral canthus is this corner. Medial canthus is this corner.
Just kind of where the eyelids meet.
Yeah, the joining of the eyelids. Conjunctiva, you can't see. I would ask it as a question, but it's a very thin layer of epithelium that covers the surface of the eye. So if you've ever had pink eye, it's wherever turned pink when you had pink eye is the conjunctiva. For the extrinsic eye muscles, you have muscles that run straight along the axis of the eye, and those are called rectus muscles. So superior rectus is going straight along the top. Lateral rectus, straight along the outside. Medial rectus, straight along the bottom. Inferior rectus, straight along the bottom. And then medial rectus, going straight along the inside of the eye. Then the obliques go diagonally. So see this one, just medial to the levator palpebrae. This is the superior oblique. And see how this blue thing is the tendon? See how it goes through a little hook and it comes back around? It like doubles back towards the eyeball. This little hook that it's looping through is called the trochlea.
Can you point out the superior oblique just one more time?
This muscle right here.
Okay.
And then the inferior oblique is this one that's going diagonally along the side at the bottom. Okay, now for the wall layers. Okay. On the very outside of the eye is the fibrous tunic, so that's the part you can touch. And that's made of the sclera, which is the white part. And then the cornea. Oh, this eye is all wrong. Let me grab you a better model. He doesn't have a cornea either. The cornea, you know, when you look at the side of somebody's eye and there's that clear dome, that's the cornea. So it's like the clear, it's like your windshield kind of in front of your eye. If you open this up, you see the second layer. It's like the middle layer. It's called the vascular tunic, and this purple is the choroid. So it's where all the blood vessels are. On this model, in the front, you've got these little red, little paisley-looking things. These are the ciliary bodies, and inside of there are the ciliary muscles. So if I point at these, I'll take either one, ciliary body or ciliary muscle, because you can't really tell the difference on this model.
Sorry, what cut of the eye is that exactly?
It's a transverse. So it's,
Transverse, okay.
the ciliary muscles go to these suspensory ligaments, which are the little white stripes around the front. And those suspensory ligaments lead to the lens, which there's never a lens.
Wait, I thought you said the ciliary body and ciliary muscles are like kind of the same.
Yeah, the muscles are in the body,
Okay.
so you can't see the difference on here.
Okay.
But they go to the suspensory ligaments, and then that's connect to the lens, which would be right in here.
Okay.
The ora serrata is this black line along the front. And on this model, so see how we had the choroid painted on the inside of here? On this model, the choroid is on the little ball inside. So it's still the middle layer, see? So you just have the sclera, you take it off, now you have the choroid right here. If you look inside of that, you can see there's cornea.
Yeah.
Wrong place, but the ora serrata is still the line in the front, and the suspensory ligaments are still the little white stripes all around the front there. And on this one, it's the same situation. You take that apart. You've got the choroid painted on this inner ball, and you take it apart, and there's the lens. You look inside, and the brown line all around the front is the ora serrata, and again, the white stripes are the suspensory ligaments. Iris is the colored part of the eye. The pupil's the hole in the middle of the iris.
What's the difference between the lens and the retina?
The lens is right, so right behind your pupil is this lens right here. It's this
Oh,
little-
that thing. Okay.
Yeah, and then that bends light so it goes back into here
Into the retina.
and hits the, it's like my eye. So it goes like that, and then the light hits the retina, which is deep inside here.
And does
So-
the cornea sit on top of the lens?
The cornea's in, okay, so first you have lens, then the iris with the pupil, and then the cornea in front of all that.
Okay, yeah.
Okay, so the inner layer is the retina, so that's in here on this model. Or if you open up this model, it's all this in here. And on this, on these, the choroid is painted on the outside, and they've got the ora serrata painted on the retina layer for both of these. For this guy, you've got the ora serrata painted on the choroid layer, just to make it confusing. And then the retina is the little Christmas ball on the inside. This one is a detached retina. So, there you go. Oh, well. Okay, so there's the retina. Rods and cones are the photoreceptors inside there. On the APR, you can see the layer where you have the photoreceptors. You don't have to distinguish between rods and cones, just know the photoreceptor layer. The macula lutea is where you have lots and lots of cones. It's at the back of the eye. It's this little yellow dot right here. And the very center of that is called the fovea centralis. And then the optic disc is where the axons for the optic nerve are leaving the back of the eye. So there's no photoreceptors there. And this, I wouldn't point to it on this model, but it's right under, actually, right here. So I'm touching the optic disc right now. This is the optic disc. So that's your blind spot. And on these models, it's a little easier to see. There's the optic disc right there. It's that white and yellow circle. The macula is pink on this one, but still right next to the optic disc. On this guy, the optic disc is a nice white circle right there, and the macula is the yellow dot here. Now for the cavities and humors, I'll ask those as questions for the most part. For the anterior cavity, it's everything from the cornea in the front back to the lens. You can divide the anterior cavity into two chambers. The front is the anterior chamber, and that's from the cornea to the iris. And then the posterior chamber is from the iris to the lens. Filling that whole cavity is a really thin fluid called aqueous humor. So that's the fluid inside the anterior cavity. And that is circulated through these things that you can only see on this model, which are called the canals of Schlemm. So little tiny canals of Schlemm.
They're like the very, very end.
Yeah, they're these little blue dots right in the front.
What's that?
Canal of Schlemm. And I was telling them my boyfriend has glaucoma, which causes his canals of Schlemm to get clogged. So it increases the pressure in the cornea, which can make your cornea burst open. So they have to clear out his canals of Schlemm every once in a while and just sort of like sandblast through them, which apparently isn't a lot of fun. But yeah. Welcome to getting older. Start to fall apart. The posterior cavity is everything behind the lens, so it's everything that fills the inside of the retina. And that's filled with a really thick fluid called vitreous humor. So that's like when you feel your eye, what it feels sort of like a grape. It's got that consistency. And for the visual pathway, you already know all of those terms, except for the optic tract, which I'll show you in a second. But they make good bonus questions to just list those steps in order. And let me get a seahorse and I'll show you the visual pathway.
What's that?
Upload it against YouTube.
Yeah, I can do that. Yeah.
Okay, so the optic tract, see how the seahorse is wearing a bridle or his reins? That's the optic tract. So this would be the optic nerve, and then it leads to the optic tract, which goes to the lateral geniculate. After that, optic radiation, that's not a structure, that's just a bunch of axons going back to the visual cortex and the occipital lobe.